All right, folks, it's Bass Action back in action. We've got our last video on matrices, and I'm going to make some modifications to this page because I typed this up in a way that I did not mean to do. So first kind of significant thing that we're going to do is we're actually just going to get rid of these steps A and B, okay? We are not going to be using the inverse at all in this page, and we're not going to find the inverse at all of a 3x3 matrix. It's overly complicated for our purposes. Not going to do it. We are going to do what's called Cramer's rule. Now, Cramer's rule is going to be optional for my students. You might be in a class that's requiring it, so this might be an extra useful video for you. I'm only going to go through the mechanics of Cramer's rule on this. If you need to know a little bit more about the why, you've got a textbook, you can Google it, or you can ask me in class, but that's not the purpose of this video. Just want to go through the mechanics. All right, so to do Cramer's rule, which is a much better option for solving a system of 3 variables compared to the row operations that we did the other day, what we're going to do is we're going to start with the coefficient matrix for this system. So writing this coefficient matrix, I am going to have a 1, a 2, and a 1, a 2, a negative 1, and a 3, and a 2, and a negative 3, and a negative 5. So there's my coefficient matrix. We'll come back to the constants in a little bit. The reason I want the coefficient matrix is the coefficient matrix is a square matrix. It has 3 rows and 3 columns. Only a square matrix could have an inverse or a determinant. So even though I'm not going to find the inverse of this, I need this square matrix so I can get its determinant. So the determinant for a 3x3 matrix is slightly different and definitely more complicated than the other one, than with our 2x2s that we did before. So what we're going to do is we're going to focus on this first one up here first. So I'm going to focus on this one, and then I'm going to imagine that this entire row is gone and this entire column is gone. So if I kind of mentally mark those out, I'm left with this little 2x2 matrix right here. Now in my previous video, 2 videos, we practiced finding the determinant of a 2x2. So what we're going to start with is we're going to take this 1 that we were looking at, and we're going to have this 1, and then I'm going to do the determinant of this little 2x2 right here. So if I do that, I'm going to have a negative 1 times a negative 5, and that's a 5. And that's going to be minus my negative 3 times my 3. So that's a negative 9. So I'm going to have a 5 plus my 9 because it was subtracting a negative. So that's my first piece. Now this next part is the one that students often forget, and this next part needs to be a minus. So be really careful. This one needs to be minus. Then we're going to focus, we're just going to move over, we're going to focus on our 2. So I'm going to have my 2. And just like before, if I imagine this whole column is gone where that 2 is, and this whole row is gone, if I can just imagine these 4 creating a square matrix, okay, a square 2x2 matrix. So I'm going to do the determinant of that little square matrix. So I'll have my negative 10, and then I'm going to subtract my 6. So I'm going to actually write that out. So I have my negative 10 minus my 6. Now the last one's going to be a plus, and I'm going to use the 1 that's at the top of this last column. And just like before, imagine this row is gone and this column is gone, and we're left with this square matrix here. So we're left with this little 2x2. We're going to find its determinant. I'll have a negative 6 minus a negative 2. In other words, I'll have a negative 6 plus 2. So I'll have my negative 6 plus 2. So now we can start to clean this up a little bit. So I'm going to have 14 times 1, 14, and I'll have my negative 16 times a negative 2, so I can now write that as a plus 32, and I will have my negative 4 times my 1, and I'll write that as a minus 4. cleaning all that up, the determinant of this 3 by 3 matrix is 42. Okay, we're going to use this value throughout the rest of our computations. Okay, so now let's take a look on how we can actually solve for each of our variables. We are going to use the constants that are on the right-hand side. So if I want to solve for x, okay, that would be in this first column, I'm going to replace all of the x's with the constants. So I'm going to take this original square matrix, and I'm going to write in the first column my 10, my -5, and a 27. And then I can rewrite the remaining two columns. So 2, -1, -3, 1, 3, -5. Okay. And then what I'm going to do is I'm going to find the determinant of this new square matrix. So if I find the determinant of this new square matrix, just repeating the process of what I did before, I'm going to have a 10. And it's, remember, I'm then focusing on this little square matrix right here. So I'm going to have a 10, and I'm going to have my 5 plus my 9. Remember, this next one, we got to be really careful. It's going to be a minus. Then I'm going to have my 2. And now I'm going to do the determinant of the matrix formed by these pieces, because I'm imagining these are gone. So then I'm going to have that 2 times 25 minus 81. You can certainly pause and check that arithmetic. Plus, my last one is going to be a 1. And I'm going to have my 15 plus my 27. Okay. Cleaning that up, I have 140 plus my 112 plus my 42. Just working that arithmetic. You can always pause the video. That's going to give me a value of 294. Now, what I'm going to do is I'm going to take this 294 that I found here, and I'm going to divide it by the original determinant. So x, I'm doing a different color here. So x is going to be 294 divided by 42. So x is 7. So I found my first variable. Now we're going to repeat that process. I'm going to slide this up. So this next one, we're going to solve for the y. So we're going to replace the y column with the constants. So my next matrix is going to look like, it's going to be, keep the first column, the original first column, 1, 2, 2. Then the second column is going to become my 10, my -5, and my 27. Third column is going to stay the same, 1, 3, -5. Okay. So following my processes to find that determinant, I'm going to end up with a 1, and I'm just going to let you pause and check these values. I'll have a 25 minus an 81 minus my 10, and I'm going to have a -10 minus a 6 plus my 1 and my 54 plus my 10. So I'll have a -56 plus a 160 plus a 64. You do have to be careful with all of your signs here, okay? So on this one, if I'm working this one out, I'm going to get, 56 plus 160 plus my 64. I'm going to get a 168. Okay, so I'm going to get my, sorry, I had to pause that there. So I get a 168. So now my y is going to be that 168 divided by the determinant of the original matrix. The original matrix was 42, that determinant. So my y value is 4. One more time, I can repeat this process. This time I'm going to replace the last column. So I'll still have the 1, 2, 2. I'll still have the 2, -1, -3. And now it's the last column that becomes those constants, 10, -5, 27. Now keep in mind, we don't actually have to go through this process. Once you know X and Y, you could go back to the beginning and plug it in, but I do want to just write this out for you so that you can see it as what it would look like. So very quickly, this would be my 1. You should have a -27 minus a 15 minus your 2 and your 54 plus your 10 plus your 10. Oops, a little bit messy here. Sorry, -6 plus a 2. So we'll have a -42, a -128, and a -40. And adding all those up, you get a -210. So following the same process that we did before, our z value is going to be a -210 divided by 42, and you get that z is a -5. But keep in mind, we didn't actually have to do this very last one. We could have taken our x and y and just plugged them in up in the top.